Okay, this is section AMU5L1a, and it's all about trig. We're going to talk in this lesson about degrees versus radians, coterminal angles, and the DMS, which means degrees, minutes, and seconds form of describing angles. All right, so let's get into the vocabulary first of all. An angle on the coordinate plane is in standard form. This is very important. When the vertex is on the origin and one ray lies on the positive x-axis. So what that means is, here's your vertex right there in the center at the origin, and here's that ray that lies on the positive x-axis. All right, the ray that's on the x-axis is called the initial side, because that's where the angle initiates from. Now the other ray, this one over here, is called the terminal side, because that's where the angle terminates or ends. All right, a counterclockwise rotation results in positive angle measures. So remember, counterclockwise, it's going to start here at your x-axis and it's going to go that direction. That's positive. And if it starts at the x-axis and goes in a clockwise way, this direction, well, that's going to result in a negative angle measure. So whether your angle is positive or negative tells you if you need to go to the left or down to the right. All right, the most common unit of measure for angles is the degree. And you see the degree symbol here. A degree is equivalent to 1/360th of a full rotation. Your whole circle is equal to 360. So every single degree is 1/360th. All right, now what we want to do is we want to look at these 6 problems and we just want to sketch an angle in standard form with the given measurement. Now we're not going to be exact, we're just trying to get an idea of where, mainly in what quadrant, would these angles be. So first let's look at our circle over here to the left, and you see this point right here, this could either be 0 if that's where you're starting, or it could be 360 if you go all the way around. So this point has 2 names. All right, here's your 90 degree, there's your 180, and there's your 270. So we're going to use those degree measures to kind of guesstimate where these would be. All right, a 65 degree angle. Well, it's going to start here on your x-axis and it's going to go this direction. It's not going to get to the 90 degree. So sketching that out would have it look something like that. All right, now for our 320 degree angle, we're going to go back and start at the x-axis. We're going to go in a counterclockwise method. All right, down to here would be 270. So we need to go a little bit further, but not quite to the x-axis. So that angle is probably going to look something like that. Now for 415 degrees, that's more than 360. So what it means is you're going to start at the x-axis and you're going to go all the way around, but then you're going to have to go a little bit more. So if you do 415 minus 360, that leaves you with 55. So that tells you you need a 55 degree angle. So it's less than 90. It would probably go somewhere off like that. Okay. All right, now for negative 140, we're going to be going backwards. We're going to go in a clockwise method. So going clockwise, this would be 90 degrees worth, and this would be 180. It would actually be negative 90 and negative 180. So where would 140 be? Well, it would come all the way over here and look something like that. Okay, now for negative 15 degrees, we're going to start here at the x-axis and go negative 15, which is not going to be very much, probably not even that much, but that's close enough. So that would be what negative 15 degrees looks like. And now for negative 210, remember if you start here at your x-axis and you go counterclockwise because it's negative, well, this is going to get you to 180. So 210 is going to be just a little bit more, maybe about right there. Okay? Now we're going to talk about radians. A radian is a unit of angle measure based on arc length. Describing an angle with a radian versus a degree is kind of like using Celsius versus Fahrenheit. They're two numbers for the same thing. Now, a radian, the degree is based on the 360 rotation all the way around your circle. Well, a radian is actually the length of the radius. If you took the radius like this and you spun it around so that it was on the edge of the circle and you curved it, those two measurements are going to be the same. This is the same as 1 radian. So we're going to have to convert, and there's simple ways to convert. But first let's realize that 360 degrees is equal to 2 pi, and 180 degrees is equal to 1 pi. The measurement in radians all the way around a circle is 2 pi. Halfway around the circle is 1 pi. Now when we convert, here's our formula. If you're trying to go from degrees to radians, you're going to multiply by pi over 180. If you're trying to convert from radians to degrees, you're going to multiply by 180 over pi. And an easy way of remembering this is that 2 goes on top. If you are converting 2 radians, then the pi goes on top. If you are converting 2 degrees, then the 180 degrees goes on top. Okay? This will make more sense when we start looking at something. Okay, so to convert degrees to radians, we're going 2 radians, so we're going to multiply by pi over 180 every single time. So to go from 60 degrees, we're going to multiply time. We're going to have 60 times pi over 180. Now we do have to reduce. When you reduce 60 and 180, 60 will go into 180 3 times. So our final answer, simplified answer, would be pi over 3. Okay. All right, now let's look at number 8. We've got 160. We're going 2 radians, so we're going to multiply that times pi over 180. Now the 160 and the 80 will both reduce by 30, so that will leave us with 8 pi over 9. All right, for 330 degrees, 2 radians, we're going to multiply 330 degrees times pi over 180, and these will reduce down to 11 pi over 6. All right, now for negative 45, we're going to multiply times negative 45 times pi over 180. This will reduce down, so you'll get negative pi over 4. All right, negative 230 degrees. Convert it to radians. We're going to multiply times pi over 180. All right, your answer is going to be negative, and 230 and 180 will reduce down to give you 23 pi over 18. They just reduced by 10. And then our last one here, negative 75 degrees. We're going to multiply negative 75 times pi over 180. So that's going to give us negative, and then when you reduce it down, you get 5 pi over 12. So notice that all of these have pi in the answer. That's how you know it's in your radians. Okay. Now, in this next section, we're going to convert from radians to degrees. So this time, we're going to multiply by 180 over pi. See up here, we multiplied by pi over 180. Now we're multiplying by 180 over pi. That's all you have to remember, 2 little conversions. Okay, so we are going to multiply 5 pi over 18 times 180 over pi. Now this time your pi's cancel out, and then the rest of your numbers reduce down, so that will give you an even 50 degrees, okay? All right, we come over here and we are going to multiply this by 180 over pi. The pi's cancel. The other numbers multiply and reduce to give you 220 degrees. All right, then for this one, we're still going to multiply times 180 over pi, and the pi's cancel out. If you take 7 times 180 and then divide it by 3, that is going to give you 420 degrees. All right, here's another one. We're going to take negative pi over 6 and we're going to multiply by 180 over pi. The pi's cancel out. We've got negative, and 180 over 6 is 30 degrees. Okay, for number 17, we're going to multiply by 180 over pi, and our pi's will cancel out. 19 times 180 divided by 12 will give you negative 285 degrees. Okay, now number 18, one last time, we're going to multiply by 180 over pi. The pi's will cancel. It's going to be negative. 3 times 180 divided by 4 gives you 135 degrees. Next, we're going to talk about coterminal angles. All right, co means together, so this means angles that have the same terminal angle. And what we're going to look at here is two angles that will have the same ending side but different degree measures. Now, how does that happen? Well, it happens when you make more than one round. Like if you start here and you go all the way around, that's 360. Well, if I go back around and in there, I'm going to have a degree measure that is twice 360. It's still got the same ending side, but a different degree measure. That's how you can tell if something goes all the way around more than once, okay? So our problems here say angles in standard position with the same terminal side are coterminal. We want to decide whether the two angles are coterminal. Well, if they are coterminal, we'll be able to take either one of the two and either add or subtract 360 degrees to get the other number. So let's look at number 19. I want to know, is 305 coterminal with negative 55? So one quick way is let's just take 305 and subtract 360, and what do you get? Negative 55. So yes, you could also take negative 55 and add 360, you get 305. So that's a yes that way as well. But either one you pick, you should be able to get the other number. All right, let's look at number 20. If I take 30 degrees and I subtract 360, I get negative 330, which is not negative 170. So that's a no. And that's supposed to be 330, not 333. All right, let's look at 21 now. These two, 21 and 22, they deal with pi. So if you remember, what was pi, or what was the radian form of 360? Well, it was 2 pi. So I should be able to add or subtract 2 pi from this number and get this number. So let's try it. We're going to have to work with fractions, but, all right, if I take pi over 4 and I subtract 2 pi, well, what is 2? I'm going to do this. I'm going to work it out this time. All right, how can I rewrite 2 as a 4 denominator? Well, that's 8. Okay, so is pi minus 8 pi over 4? What is that equal to? 7 pi over 4, not 9 pi. So that's a no. All right, let's look at this next one. So number 22, I'm going to take 3 pi over 2, and I'm going to subtract 2 pi. And sometimes you might have to subtract more than a 2 pi. Sometimes it's been twice around. So if I do 3 pi minus 2 pi, or 3 pi over 2 minus 2 pi, all right, what is my common denominator going to be? 2. Well, that's going to be 4 pi. So what I have here is negative pi over 2. Well, I might still be able to go again because this is just larger. So I'm going to subtract, and let me just go ahead and put it over 2. So that's going to be 4 pi over 2 again. Negative pi minus 4 pi is equal to negative 5 pi over 2, and that does match this. So the answer is yes. Okay, and it's a little bit easier to understand down here in these next problems because you are going to be creating the coterminal angles for each given angle. And it wants you to find one positive and one negative. So what we're going to do is we're going to add 360 and we're going to subtract 360. Or we're going to add 2 pi and we're going to subtract 2 pi. So let's take 150 and we're going to add 360. So that gives you 510 degrees. And you know, if we wanted another positive angle, we could just add 360 to 510. You can just keep on going. All right, if I want to find a negative angle, I'm going to subtract the 360, which is going to give me negative 210. And once again, I could subtract another 360 and get another angle. All right, let's do 265. For 265, I'm going to add 360 degrees, which will give me 625 degrees. And I'm going to subtract 360. 265 minus 360 equals negative 95 degrees. And then one more on the degree. I'm going to take negative 25 and I'm going to add 360 degrees. So that's going to give me 335 degrees. Then I'm going to take negative 25 and I'm going to subtract 360 degrees. And that's going to give me negative 385 degrees. Both of these would have the same terminal side, but they would just go around more times. Okay? Now for these down at the bottom, we're going to be doing radians. So we're going to add 2 pi. If I take pi over 12 and I add 2 pi. Remember, when you add fractions, you've got to get that common denominator. So what is 2 over 12? Or what would I rewrite it as? Well, that would be 24 pi over 12. And then we're going to reduce that down, or we're going to add this together. So 1 pi plus 24 pi is 25 pi over 12. And that won't reduce. All right, now we need to find the negative one. So I'm going to take pi over 12, and I'm going to subtract 2 pi, which we just figured out was 24 pi over 12. So I'm going to take pi over 12 minus the 24 pi over 12, and that's going to give me negative 23 pi over 12. Okay, number 27. I'm going to take 7 pi over 6, and I'm going to add 2 pi. And I'm going to rewrite 2 pi over the common denominator, 6. So it's actually over 1. If I multiply the denominator by 6 to get this number, I've got to multiply the top by 6. So that's going to give me 12 pi. And 7 pi plus 12 pi is 19 pi over 6. All right, now when I subtract, that's going to be 7 pi over 6. I'm just going to go ahead and grab my common denominator over here, minus 12 pi over 6. So 7 minus 12 gives you negative 5 pi over 6. See, it's that simple. If you're doing degrees, you're going to add and subtract 360. If you're doing radians, you're going to add and subtract 2 pi. Okay, the last one, I've got, if I take negative 11 pi over 18 and I add 2 pi, get a common denominator, put both of them over 18, and then add, that should give you 25 pi over 18, and that won't reduce. All right, if I take negative 11 pi over 18 and I subtract 2 pi, get a common denominator, that's going to give me negative 47 pi over 18. And that is the end of the first half of Lesson 1.